So from now on, you can't see it, but yeah, I'll start recording the lesson for you, and then I'll just send it to you after the lesson together with the notes.
Okay.
So your task is to go back and redo these questions, okay? Because in class, I'll just walk through them with you, but you don't have time to do them by yourself. So you have to go back and actually redo all these questions by yourself in order to be sure that you can do it. Okay, so now let's try question 4A3. So 4A3. When I see an equation like this, 1 over 2x plus 2, what I pay attention to is the denominator, right? So the denominator will determine what number you choose for x. So what do you think the number you should choose for x is?
2.
2 and? Just need 2 points, right? So 2 and?
4.
And 4, yes, correct, you're correct. So basically the number needs to be able to cancel out the denominator here, right? So when you substitute 2 in, what's the y value?
Isn't it 3?
It's 3, yes, correct. How about 4? When x equals to 4?
4. 5.
5 or 4?
Wait, it's 2. It's 4.
It's 4, yes. Okay, so same set of axes to draw the graph of. Okay, I'll get one of the.
Well, actually, I did get one homework, but I think I got like one homework.
Ah, okay. Is that long?
Not really. It's 9. I think it's 9 questions.
Yeah, should be alright. So depending on how many questions we can go through in 1.5 hours. So they are the ones that you need to redo. But anyway, let's say this one here, and then we'll just keep on adding to the same graph. But yeah, so 2, 3, 4, 4. If I were to take this one as a center, maybe this one as center is 0, right? And each tick is 1, 2. So 2, 3 is here, and then 4, 4 is here, right? So to draw a straight line between these two, you just need to keep on extending them. So what you can pay attention to is the gradient. So the gradient is 2 right, 1 up. Right, which means, well, normally when you have a ruler, it will, when you have a ruler, it will be a bit easier to sketch these ones out. But as long as you keep the gradient 2 left, 2 to the right, 1 up, then you should be able to basically sketch a line, something like that. Right, and then let's draw in the axes. Oh, push that down, that's okay. Roughly like so. Okay. All right. Now, how about a question like 4? So for a 4, y equals to negative 1 over 4, x plus 2. Let's choose 2 values of x again. What would you choose?
2 and 4. 4 and 8.
You can choose 4 and 8, but because it's negative, right? So I would actually pick a number that is positive, which is 4, and a number that's negative. So I'll just go negative 4 and 4.
Okay.
Yeah. So negative 4 times into this would be?
Just negative 1.
Not quite.
So, 4, negative 4, positive 4 over 1.
Not quite.
Plus 2, 6.
Not quite. So when you multiply with negative 1 over 4, it will be positive 4 on 4, which is 1.
Okay.
And plus 2 is 3. Okay, so what if I substitute 4 into the equation?
It's still it's negative 4 and 4.
Is negative 4 and 4, yes, which is?
Plus 2, negative 2, negative 4 and 4 is negative 1 plus 2, so 1.
1, yes. Okay, so negative 4, 3 and 4, 1. So negative 4, 3 is here and then 4, 1 is here. Right, so this will be the new line. It's a bit hard to sketch with our ruler, but it's roughly from here to here and then something like that. Okay?
Yeah.
Yeah? Alright, so any question for these types of questions here?
No.
No? Pretty easy? Yeah. And I think the relationship question, some of them will be perpendicular. You will see some that will be perpendicular to another, but not sure if that's what they're expecting you to find. Let me see. So this is chapter 18. B. Oh yeah, okay. I think when you draw this, you will see that they are all concurrent. So it all passes through the single point here, which is a 0, 2. I think that's a case. It's about concurrency. But yeah, that's about it. Now let's move on to 18C, which I think will be the harder one, right?
Yeah.
Points and lines. Okay. Find the coordinates of the points on the graph for the given x value through for the straight line graph. Yeah. Okay. Does that one make sense?
Yeah.
Sure?
Yeah.
Yeah, easy, medium, hard for you?
Easy.
Easy? Okay. How about this one?
Is y wait, so is it 11 equals 4x minus 5?
Yeah. And then you solve for x.
Okay, yeah, easy.
Easy? Okay. Check whether or not each of the following points lie on the line. How would you check for them?
I don't know.
You don't know? Okay, alright, let's start here. So I'll revise a bit of, I think I get where the confusion lies now. Let's go through it. So 18C is about points and lines. So the idea of a line, for example, let's say this equation here. So that would be y equals to 2x minus 1, for example, right? So a line is actually a collection of all the points. It's an infinite number of points where the x and the y value satisfy this equation.
Okay.
Right? So what it's saying is that any y value, so let's just say if I pick this one and then I say the x value, so it will be the x comma y coordinate, right? Let's say I pick this random point down here and I say, okay, x equals to 1, what's the y value? Then essentially you're saying that, okay, the y value must be 2 times the x value minus 1, because it's the same relationship, right? It's on the same line. So that would be 2 times 1 minus 1, which is 1. So that would be the point 1, 1.
Okay.
Okay? Let's say I pick another point down here. This one, and I'm going to say that, okay, this one, the y value, I don't know what the x is, but the y is negative 2. How do we find the x value? Well, again, it's on this line, which means that you substitute the y value in. So negative 2 must be equals to 2 times
What, negative 1? Oh, 2 times x?
2 times x minus 1.
Okay.
Right, so you're going to work it out.
Okay.
So you're going to add both sides by 1, which makes this to negative 1 equals to 2x. Yeah, and divide both sides by 2, so that's negative 1 over 2 equals to x. So it's saying that the x value here will be negative 1 over 2 or negative 0.5.
Okay.
Okay? Yeah. So that's the idea behind like points on a line. is that the x and the y value, when you punch these values into the equation here, it must satisfy. The left hand side must be equal to the right hand side. Okay. So imagine if I take another point, let's say this is 1, 1 is on the line, right? If I pick a point above that, x is 1, y is 2. Is this on the line?
No.
No, because the y value, in order for it to be on the line, this is not the right y value. It must be 1.
Okay.
Right? And so if I were to ask you a random point, let's say the point is 3, 4. Is this on the line?
No.
How do you know?
Because it's the y value is not 1.
Not quite. The x value is 3. Do you know where what the y value is supposed to be?
Oh, it's supposed to be 2. It's supposed to be 3, right?
No. It's supposed to be whatever value that this x will take. Oh. So essentially, to test this point, right, you need to sub x equals 3. Okay. Right? Because we're talking about this line here. So the y value must follow the exact same.
5 then.
Has to be 5, yes. So then you would get y is equals to 2 times 3 minus 1, which is 5. And because this y value is 4, it's saying that 3, 5 is on the line. So let's say this point here, right, is 3, 5. Yeah. This one is on the line. 3, 4 is 1 lower. 3, 4 is 1 lower. So this is not on the line. Okay? So coming back to this question here, this is how you're working these ones out. So give me an explanation. How would we find out whether these points are on that line?
So 3, 9 would do the y equals to 6. Yeah, so that one is the first one.
Yep, for question A, so you would write sub x equals 3, right? So then y would be 2 times 3 plus 3, which is 9. Therefore, 3, 9 is on the line. Right?
Yeah.
Same thing for question C.
So we got x equals 2, negative 2, negative 2 over 3. Negative 2 over 3 plus 3. Negative 4 over 3. That's there's just 3.
How do you add them together?
2 and 1, 2 and 1 over 3.
Yes, that's right. But it's best to just convert that to a fraction, so 9 over 3. Right? Okay. When you subtract it, it will be 5 over 3.
Okay.
If you want, you can write this as 1, 2 over 3. Yeah. It's 1, 2 over 3, or you can write it as 5 over 3. But basically, y is not 0. So because this y is 0, it's not on the line. So therefore, negative 2 on 3, 0 is not on the line. Okay? All right, next example. So let's say this one. How do you find the values of A, B, and C? How do you find A?
A is y.
Yep, but you want to find the value of A.
Then you do. You do x equals 4y.
Not quite.
X equals 0y.
X equals to 0 and then find y. So the actual step, so what you would say is this. So let's say this is a question, right? So what you would say is sub x equals 0 into the equation. Okay, does it make sense? So question A, right? Or let's say find A. So you have to find A because the point A is 0A, right? So you would sub x equals to 0.
Okay, yeah.
Right?
Yeah.
And then to find y. So that'll be y equals to 4 times 0 plus 3. 4 times 0 is 0, plus 3 is 3. So y equals to 3. Therefore, A equals 3 because A is the y coordinate.
Okay.
Okay. So how do we find B?
sub y equals 0.
Correct.
Yeah, sub y equals 0.
Mm-hmm.
And then x equals
Alright, so remember, we're working with the same equation. So when you sub y equals to 0, instead of writing y, you write 0.
okay. So
Alright.
0 equals 4x plus 3. So then x is b, right? No, x is 0, x is y, right? No, x is 0.
Y is 0.
Oh, so x is
So we're trying to find x.
b.
Because b is the x coordinate, where the y coordinate is 0, and b is on the line.
Okay. So
So it's just solving for x.
x is, isn't it b?
It is b, yes. So you can technically, if you want, you can technically write 4b plus 2.
Okay.
Right? Because sub y equals to 0, x equals b. Right? Because the point is b0.
Yeah.
Yeah? So similarly, sub x equals to 0 and then y equals a. So technically you can just write a equals that.
Okay.
Same thing. Okay?
Okay.
Yeah, so you just gotta solve for it. Alright, make sense?
Yeah, a little bit more.
Okay?
A little bit more.
Okay. Now find c.
See, sub x equals 1.
Mm-hmm.
And then c equals 4. C equals y equals c equals 4 times what? Y 4.
4 times. What's the
1
x?
is a 1.
Yeah.
Plus 1. I mean plus c
Plus.
3.
Yeah.
That is 7.
7. That's right. So yeah, so that's how you find A, B, and C. The main idea, the main line of ideas here is that if you're working on a line, right, any point on the line would have an x and y coordinate. You just sub those values into the line equation.
Okay.
Yeah, and it must satisfy. So that creates an equation, and then you can solve for the point.
Okay.
Okay. All right. So that's so far. That's for this example. Okay. So these are example 10 is the one that's closest to that one. Let's try this. Let's try these ones. Straight to the deep end. All right. Write down the x coordinate. I'll give you some time to work out question 13. Here, grab some paper. Oh, yeah.
Getting pencil case.
Okay. So remember, the technique to do this one is always sub something equals something.
So x equals. Wait, am I doing like sub x?
What do you know?
The point. equals 70.
What point?
The y point.
Yes, the y coordinate. So
you have to sub the y coordinate, right?
yes.
Sub y for
What's the value of y that you will sub into the equation?
72.
Yeah. So sub y equals 72.
Yeah. 72. So 31. X is 31, right?
Yes, but you should work it out bit by bit. So like subtract both sides by 10 and then divide it by 2. At least write the step where you subtract both sides by 10. You don't need to actually do it mentally. It's best to write out step by step.
Okay.
Okay. Now question 14. Find A first. Remember, you're always subbing something in, yeah?
Yeah. So sub -1 for y.
What
Sub x for a.
No, what's the coordinate? Which one goes first?
X. So -1. So sub x for -1.
So normally what you write is this. You would write sub x equals -1 and y equals a, because the equation has y, right, equals to -5 times x, right? So when you sub x equals to -1, you should also write that sub y equals to a.
Okay.
And then instead of writing y and x, you write the two new things. You got B and C.
Yeah. Yeah. Negative 5b.
Negative, what's b?
5b. Negative 5.
B is negative 5? Not quite. Yeah, 15 equals negative 5b, yes. You know, we gotta solve for what it is.
Oh. So, b. Wait, different like b equals.
No, this is solving. You just have an equation, so you gotta solve for it.
Negative 3.
Yeah. I think of this as dividing by negative 5 on both sides.
C equals negative 4.
Not quite.
Oh, it's negative 20. C equals 4.
Yeah. Okay, does that make sense?
Yeah.
It's just substitute values in. So now we move on to 18D. What chapter is the latest chapter that you're doing at school?
No, I think it was 18 C.
C and D?
Yeah.
Okay. Because it goes all the way to E, F, and G. So 18D, E, F, G. Yeah, I think we might end up. Maybe let's just go through all of them first.
We can do this.
State the y value of the y-intercept. Yeah, so that's that's 18D, the y-intercept and the gradient of the line.
Can we do this then?
Yeah.
Okay.
Yeah, we're doing this one next. But have a look at the screen. That one I'll leave you to do it for homework. I'll explain the main concepts first. Okay, let me see. Okay, maybe I'll jump ahead. I'll teach you the main concept even for the next chapter as well. So I'll group 18D and 18E together. Okay. So so when you have a line, right? Like say that line there. The y-intercept is the point that it cuts through the y-axis. Okay, like this point here. So this is the y-intercept. Okay, what are the coordinates of this point?
Why? Wait. I don't know.
You don't know. Do we know the y coordinate?
No.
No, we don't.
So we just write y?
Yeah, we just write y, and then what's the x coordinate?
X.
We do know the x coordinate.
We do?
Right, when you look down at the x-axis, what's the value?
5.
What's the point that the intersection of x and y? Alright, what's the point here?
Oh, that's 0.
0, yes, so x coordinate is?
0.
Is 0. So for the y-intercept, the x coordinate is also always 0.
Okay.
Right? So to find the y-intercept, right? To find the y-intercept, you essentially just sub x equals 0 and calculate y. Done.
Okay.
Alright?
Okay.
That's it. Now, in saying that though, there is, and then, okay, so the gradient is like the slope of the line. Okay? Now, so that's the y-intercept, and then I'll cover a bit of the gradient. So the gradient is also called the slope of the line. Right? So you could either have a positive gradient when it's slant to the right like that. Okay? So imagine that if you have a center line here, right? If it's slant to the right, it's positive because as the x increases, y increases. Okay, so imagine you're always going left to right. Yeah, if you're here and you're going that way, you're going up. That's why it's positive, right? And then the slope is negative when, again, you're on the line, like you are here, and then when you go left to right, you're going down. So that's negative. Okay, so that's positive and negative slope. Now, how do we calculate the slope of the? Okay, let me see if you are supposed to learn this one yet.
Oh yeah, we are.
Do you know the formula to find the gradient?
Yeah, I did it in class. Yeah.
Oh, rise over run. Okay, so you know the rise over run formula, right?
Yeah, this is the one I did in class.
Let's see. Okay, alright. Yeah, so okay, so you have learned rise over run. If you have learned that one, let me teach you something a little bit more advanced. But something that you're supposed to learn next year. Yeah. It's technically next year content, but it's the same, it's related to this concept here. So
can we do rise over run again?
Yeah, that's what I'm going through now. So the gradient is equals to rise over run. Alright. Okay, so the gradient is rise over run. That's why when you're talking about the negative gradient, what's the rise? The rise is negative, right? Because from this point to this point, it goes down.
Yeah.
Right. So note that the run is always positive. It's always left to right. Yeah. But in this case, so this one when the gradient is positive, there is a positive rise. Right? But when the gradient is negative, it is a negative rise, so it's going down.
Yeah.
Does it make sense?
Yeah.
Yeah. So rise is always the y coordinate of the second point, which is of the final point, which is the point on the right, minus the coordinate of the left point. So for example, okay. So for example, right? Let's say I have this line that goes like that. Okay. So y equals to 2x plus 1. So when so let's just substitute to get a few points. When x equals to 0, y equals to?
0, y equals to 0, like, 1.
Equals 1, yes, because when you sub 0, would be 2 times 0 plus 1, right?
Yeah.
And 2 times 0 is 0, plus 1 is 1. Now, when x equals to 2, y is?
5.
Is 5, very good, okay. So 0, 1, and 2, 5. Now, rise is like you're taking the y value of the difference in the y values. So it rises from 1 to 5. What's the rise?
4.
It's 4, right? What's the run?
It's 2.
It's 2. So it's 4 over 2, which is 2. The gradient is 2. Okay?
Yeah.
Now, let's take a slightly different graph. Say this one. Let's say this point is this is 5 and this point up here is 4. What's the rise?
The rise is -1.
Okay, if you say -1, what's the run?
The run is there's no run.
There is a rise and a run, so be very careful. This is the x-axis, that's the y-axis. When you're talking about rise, it's like the y value from one point to the y value of another point. So you're looking along the y-axis here. Okay. Right? So it rises from what to what?
4 to 5.
No.
5 to 4.
No. So this is, I tricked you a little bit by putting this value as 5. So the tick mark on the number line is 5, but it's on the x-axis. What is the actual coordinate of this point?
Is it 0, 5? 4, 5?
What's the x coordinate?
X coordinate's 5.
Y coordinate?
4.
4 will be here. 5, 4 is here.
Oh, okay. So 5, 0.
0, yes. If it's on the x-axis, y coordinate is 0. What's the coordinate of this one?
That's full 0.
Nope.
0, 4.
0, 4.
Yeah.
So what's the rise here? It rises from?
5. It rises from 0 to 4.
Nope.
Oh, 4.
You actually should say from left to right. So what's it goes from?
4 to 0.
Which means it is?
Negative 4.
Negative 4. It's, it's an inverse rise, right? It's actually going down.
Yeah.
Yeah, so the rise is negative 4. What's the run? The run is normally always
5.
positive.
5.
It's 5, yeah. So the gradient is negative 4 all the time. Okay?
Yeah.
Make sense?
Yeah.
Yeah. So that's the rise and the run concept. You always take the second point, right? You always look at a point on the right and then you subtract the y coordinate of the. So this one actually I would write it as. So the formula you will learn later is y2 minus y1 over x2 minus x1.
Yeah.
So y2 is like the point number 2 here. y1 is the point number 1 here.
I think I already did learn that.
Did you? I didn't see that in the formula, but that's okay. It's basically the same idea. You will learn this sooner or later.
Yeah, okay.
Okay. So yeah, so y2 is 0, y1 is 4, x2 is 5, x1 is 0.
Okay.
Does that make sense?
Yeah, it makes sense.
Yeah, it's just the x and y coordinate of the 2 points. Normally you take the point on the right as number 2. That's common.
What is the m?
We'll get to that in a second. So let's go back to this one here. Alright, so let's go back to this one here. And I'm going to introduce you to the line equation. Line equation. Every line can be written in this form. And that form is y is equals to?
Y is it 5? What?
This is the generic line equation. Have you seen this?
No.
No, because this is in 18D.
Okay.
Okay, so this is a line equation. So that's where the m value is coming from.
We haven't started the 18D yet.
Yep. So I'm just covering that first for you.
Okay.
So line equation is y equals to mx plus c. This is the m that you're talking about.
Yeah.
Okay. So y equals to mx plus c. This is the generic line equation. M is the gradient, and c is always the y-intercept.
Okay.
Okay. So this is the gradient intercept form of the line.
Shouldn't it be G?
Yeah, you can write G for gradient, but normally the formula is y equals mx plus c. That you were asking what was the m value? Is this m is the gradient?
What is C for?
C is the y-intercept.
What does it stand for?
Constant.
Okay.
It actually stands for constant. So it stands for something called constant term.
Yeah.
That you will learn later when you start learning quadratic equations. But basically, a constant term is a term that doesn't have x in it.
Okay.
Right? Doesn't have the main variable x in it. So C stands for constant. Right? And m is just gradient. I can't remember. I think m probably comes from like a Greek word or something. I don't remember what it is. But the line equation is just y equals to mx plus c. Now, what's the m and the c in this equation?
M is C is 11.
No. Oh. How did you see 11?
5. Oh no, it's 5. Isn't it 5?
C is not 5.
Okay, wait.
We're comparing. Right? We're literally just
1.
C is 1. M is
2x. 2.
It's just 2 because it's m times x, right?
Yeah.
So m is only 2 and c is only 1.
Okay.
So if you look at that equation, what's the gradient of the equation of the line? You don't even need the rise over run.
It's y equals mx plus c. right?
Yeah, and m is the...
Oh, it's 2x. It's 2 plus 1. 2 x plus 1.
So what's the gradient?
2.
What's the y-intercept?
It's 1.
Yeah. That's it. Okay? Now the trickier thing is actually to work through the question. Let me just go straight to the questions here. Okay, so this chapter is teaching you the basics of finding the y-intercept, which is, remember I said earlier, it's on the y-axis, so the x-coordinate is 0, right? But using the mx plus c, can you actually find the y-intercept straight away for question A? Yeah, let's just read out the answer. What's the y-intercept for question A?
It's 3.
It's 3, yes. Y-intercept for B?
7.
Not just 7?
Negative 7.
Negative 7. Y-intercept for C?
5.
Y-intercept for D?
Negative 8.
Y-intercept for E?
X. No, 5.
No.
What? It's 5x.
No. It's the
Zero.
Yes, it's 0 because the constant term is plus 0, right?
Yeah.
Now, the question that I saw in your homework looks something like this. Right? Find the gradient. Find gradient and y-intercept of y is equals to 4x plus 2 over 3, for example. How do you find the gradient and the y-intercept? Well, generally, to find the gradient, you will need to find 2 points and then do rise over run, right? But it could be a little bit tricky in this situation. However, if you can convert it into the y equals m times x plus c, you can read the gradient and the intercept straight away. Okay. But how? How do we do it for this question?
So the gradient in that one is 2, right? I don't know, it's
No.
4. And then
No.
What?
Because it has to divide by 3. You can't have anything. This is just x. There's no
okay.
x divided by anything. So how do we get rid of the divide by 3?
Times by 3.
Good guess. Good guess. But if you times it by 3, you get 3y. This is only 1y.
Okay. So I'll move the terms.
What do you mean by move the terms?
Or y means like move 3 on top and the times instead of divide.
Not quite. Now I'll show you the technique.
I said the x. I said the x and y.
Yes, but how?
Can't you just move the x over? Then it would be like y over x.
No. Because you have to deal with the divide by 3 first.
Okay.
That's what I'm asking. How do we deal with this one? How do we split that? So you see how this one is supposed to be 2 terms, right? Mx and c, right?
Yeah.
This one right now has only 1 term. But the top is 2 terms.
Okay.
The bottom was only 1. So how do we do this? Remember when you add a fraction, you do a plus b over c, right? The step before that is this. Yeah? This is called splitting up the, I call it splitting up the fraction.
Okay.
Right? Split up the top.
4x over 3.
Yes.
2 over 3.
Correct. So what's the gradient and the y-intercept?
Gradient is 4x and...
Not quite.
4, just 4.
Not quite.
I have to divide by 3 first, right?
Nope.
It's just 4x over 3?
Nope.
Gradient.
I'll tell you the definition again. Gradient is m. What's m? M is the number that multiply into x to get the x term.
4.
Not just 4. If it's 4, then it's going to be, if gradient is 4, then it's supposed to be 4x only.
Okay.
But this is 4x over 3. Now the trick is to realize that this is the same as 4 over 3 times x. Right? Because when you multiply by a whole number, this one is just multiplied to the top only.
So it's 4 over 3, right?
Yes, it's 4 over 3. Okay, so the gradient is 4 over 3. If you didn't know how to split this up, you have to find 2 points, do rise over run, and do a bunch of calculations. But if you know how to split that up, instantly get the answer.
Okay.
Right? And then what's the y-intercept?
It's 2 over 3.
Yeah, it's 2 over 3. That's right. Much easier, right? Yeah? So that's why I'm teaching you like this slightly advanced concept of how to manipulate the line equation. Most of the time you can do it that way. Now, what's the y-intercept for question A?
Y-intercept is 3.
Okay, what's the y-intercept for question D?
it's 1. No, yeah, 1.
Yeah, it's 1, but that's strange. It should be -1. Should be -1 because that's below the x-axis. Alright, that's fine.
Why is A the first one?
2a is 3.
Yeah.
Yeah, because it's the point on the top there,
Yeah. Okay.
right?
Yeah.
And then it's basically the point on the y-axis
Okay.
that the line cuts through. Alright, for each of the 4 equations below, make up the table of values for -1, 0, and 1. It's just substituting in, get the point, draw the graph, find the gradient. Yeah, no, that's just rise over run stuff. Okay. I'll just show you one of these examples, like just the last one. The concept's not too hard, but it's a bit, I think this is more basic than the other one. Alright, find the points on the line that have the x values 1 and 2. So what are we doing here? Let's say for question A.
One, two, so y equals,
Remember, you always write
okay.
sub.
So sub x for 1.
Yeah, so sub x equals 1.
Okay, so y equals -3 times 1. -3.
And then?
So 1 x equals sub x for 2. And y equals -3 times 2. And that's -6.
Okay, so the first point is 1, -3, and then the second point is 2, -6. Okay, how do we find the gradient of the line?
I find the rise and run.
Yes, rise over run. And what's the formula that I said earlier? Y something something.
So first the run, no, the rise.
No, we'll just use this formula: y2 minus y1 over x2 minus x1. So normally I take the second point as this one, and then this is the first point.
Okay.
Right. Now sub the values in. What's y2?
Y2 is 2, no, 6, no, -3, -6.
Yes.
Okay.
Yeah, it's a y coordinate of point 2.
Oh.
Okay. Minus what's y1?
-3.
Yeah. So note that when you sub in these values, I like to put them in bracket because you might minus.
Yeah.
Alright. Okay. What's x2?
Negative, no, 2 is 2, and 1.
Yeah. Okay. Then you work it out. So minus is a plus, and the bottom is just 1. So that'll be -3 over 1, which is -3. The gradient is -3.
Okay.
Make sense?
Yeah.
Yeah. So essentially, rise over run is one formula, but the one that you actually use a lot more in terms of calculation is y2 minus y1 over x2 minus x1.
Okay.
Okay?
Yeah.
Yeah, that's essentially your rise over run, but in x and y terms. Okay, so this chapter 18E is what I just went through with you, where it's a form y equals to mx plus c. M is the gradient, c is the y-intercept. Okay? Why is c the y-intercept?
Because
Can you reason why is c the y-intercept always?
no.
So what happens at the y-intercept? What does it mean?
It's just where the y meets with x.
Where the try that again?
Y it's a way it meets with the y line and the x line.
Where the line meets the
Y intercept. Y with line meets the y intercept.
y
Line.
the official name is
Y axis. Oh yeah, y.
yes, where the line meets the y-axis, which means
that's the y intercept.
yeah, it's a y-intercept, which means aka
Y intercept.
something about x.
X, it's where x meets on the y axis.
No, so y-intercept is where the line meets the y-axis. So far so good, right? AKA, which means in other words,
Yeah.
when x equals to
y times
Any point on the y-axis, what's the x-coordinate?
isn't it x? What?
If it's on the y-axis, what's the x-coordinate? Like these points, all these
0.
points. 0, yes. This could be 0, 4. This could be 0, 2. This could be 0, minus 1. This could be 0, minus 2. They all share the same?
So x point axis.
Use a proper term. X, I would see.
Constant.
Coordinates. Yes, okay. They share the same x-coordinate. Alright? So that's what it means by on the y-intercept. So when x equals to 0, this is important because this is how you find the y-intercept. Because you sub x equals to 0.
Okay.
Right? For any line that cuts through the y-axis like that, the y-intercept is just sub x equals to 0. Because we know that that point has the x-coordinate 0 and then an unknown y-coordinate or y-intercept.
Okay.
Okay?
Yeah.
Now, when x equals to 0, what happens to this part of the equation here? Alright, so we're not working with actual numbers, but let's just say we work with this formula.
M times 0?
Yeah.
X with M. Yeah.
Which is?
It's just M 0 plus C.
M times 0 is?
M 0.
It's just 0. Plus C is?
C.
It's just C.
Okay.
Okay?
Yeah.
Therefore, C is always the
Constant.
It is the constant, but in this case we're talking about the
Y-intercept.
y-intercept.
Okay.
Okay, does it make sense?
Yeah.
Yeah, because whenever you find the y-intercept, you sub 0 in and this whole thing just becomes 0.
Okay.
Which means the y-intercept is always going to be what the constant term C is.
Yeah, okay.
Okay? Alright, so let's try some examples from 18E. Pretty easy. Okay, let's say this one. So yeah, this is going to be 18E. Alright, which of the lines y equals to 4x minus 6 and y equals 6x minus 4, which is steeper and why? Right, which one is steeper and why? Which one has higher slope is essentially what they're asking.
6x minus 4.
Yes, so y equals to 6x minus 4 is steeper because?
Because the y-intercept is...
No, it's not the y-intercept.
It's because it's
We're talking about slope. What represents slope?
it's higher x-intercept.
No,
No, it goes higher. It's a y-intercept slope, right?
No. The gradient is the slope.
Oh, okay.
Okay? So why is y equals 6x minus 4? Why is it steeper? What's the gradient?
The 6x.
The gradient is the number that times into x.
Okay. So it's x, right?
The formula is y equals to mx plus c, where the m is the gradient and c is the y-intercept.
Yeah.
So what's the gradient in this equation?
6.
Yes, the gradient is 6.
Okay.
Okay, maybe backtrack a little bit. Example 15, find the gradient and x-intercept and y-intercept of these lines. Question A, what's the gradient?
7.
What's the y-intercept?
It's x. Y is 4. -4.
Negative 4, yes. Question B, what's the gradient?
Just 0. Negative 0.
No. If it's 0 times x, it's 0.
Okay, so it's negative x.
No. It's the number that times into x.
3.
Or the coefficient of x. No, 3 is not the gradient. It's m is the gradient, right? mx plus c. M is the gradient. What's the number that times into x?
Wait,
It's not negative.
is it 1?
It's not just 1.
-1.
It's -1, yes. Okay? Because to get negative x is -1 times into x. So the gradient is -1. What's the y-intercept?
3.
3, yes. Okay? So that's the answer to example 15. Now, so the answer for example 16, the gradient of the first line is 4, the gradient of the second line is 6, and therefore the line y equals to 6x minus 4 is steeper because the gradient is higher.
Okay.
Right, so gradient is essentially slope. Now let me give you a visual demonstration of this. Y equals mx plus c. So this is a very basic line. Right? And then I'll put in the point as when x equals to 0, c. Okay, so it doesn't matter what the c value is, it will always be the y-intercept. Okay, so see, this is the y-intercept, right? So let's say y-intercept. Okay, so that's a y-intercept, yeah? And when I move the c value, so let's say I move it up, see, it's just moving the graph up. Later you learn this is vertical translation, literally shifting it up. Okay, but yeah, so if the c value is 4.3, okay, let me just maybe change the step 1. Right, if I move it to 5, see, it just jump up.
Okay.
Right, if the c value is 0, then it goes to the center, and then if it's -1, then it cuts through -1.
Okay.
Yeah, so the c value there is always going to be the y-intercept, and the gradient is a slope. So if you have a positive slope, let's say from -5 to 5. Okay, so right now the slope is 1, right? If I increase the slope, what do you think? It will be
It's gonna change.
steeper,
Yeah.
right? Like when the slope is 5, it's a lot steeper than when the slope is like 0.5.
Okay.
You see that? Note how it always turns around the y-intercept because the y-intercept doesn't actually change. Right? You see? Because if the c value doesn't change, the y-intercept doesn't change. Because c is literally the y-intercept.
Okay.
And m is only the slope of the graph, so like which is steeper. Like of course this one is steeper because the m value is 5, the gradient is 5. What if it's negative?
We'll just make it
It turns the other way.
Yeah.
Like that. Right? So a steeper negative slope, like the more negative it is, the steeper it is. It's just going down, right? It's just going from left to right down. Yeah, but the larger the numerical value, like -5, is steeper than say -0.14.
Okay. Yeah.
Okay, does that make sense now?
Yeah.
Yeah, so that's a visualization of the formula y equals to mx plus c. Okay, what's the value of m? How do we find the value of m in this equation here? How do we find this? What is m?
M is the gradient, right?
Is the gradient. Is there another way to find gradient?
Substitute.
What's the formula?
Well, m equals. Wait, y equals m x plus c.
Yeah, so we know so we already know what the y-intercept is, but how do we find gradient? There is another way to find gradient.
If you sub in x with y-intercept.
No. There's a formula for it.
m x over 2.
Not quite. Gradient is slope, and slope is something over something.
Yeah, isn't it rise over run?
Yes, it is rise over run. There are many ways to find the same thing. Okay, so the idea behind this chapter is that you need to connect a bunch of concepts together.
Okay.
All right. So rise over run. Another formula for this is
m of x.
no.
What isn't it? Isn't it mx over 2?
No. What's a rise?
The rise is y.
Yep.
And run is x.
Yes, rise corresponds to y, run corresponds to x. So the rise formula is something minus something.
Yeah. Wait, so I have to find y, right?
Yes, but tell me the formula
x2,
first.
y2.
Y2.
Yeah, and y1.
Yep, and then over.
Y.
Run
x,
is.
x 2. Is that like squared or something?
No, x2 as in like the second x.
Oh, okay, x1.
Yeah, so squared is like that, right? We're doing x2, which is the second x value, and y2 is the second y value. So again, what's the x1 value?
X1 value is just.
Yeah, let's go to the order. What's y2?
Y2 is. Isn't it m?
No, we're not looking at this one anymore. We're actually looking at.
Oh, okay. 1.
Right, the y coordinate of the second point. We've got 2 points here.
Which one are we doing first?
Normally you go left to right on the line. So if you look from the left to the right of the line, the first point is the first one that you see.
Okay.
Second one is the second one you see.
0.
Y2 is 0? No.
Alright, 2. 2 and. No. 6 and 2.
6 and 2. So 6 minus 2, and then the x value is?
1 and 0.
1 and 0. So the gradient is?
4 over 1. No,
Which is 4.
Yeah, okay.
Okay? Yeah. So which means that this equation will be y equals to 4x plus 2. How do we test if this point is on the line?
We substitute x for 4.
We substitute x equals to?
2, okay.
Equals to what value?
Is it 0?
Yes, that's right. You substitute the x as the x coordinate of the point.
It's 2.
Yes, so that'll be y, which is 4 times 0 plus 2, which is 2. So y is equal to 2 and x equals to 0, which is correct.
Yeah. Okay.
Alright, so the point is on the line. Okay, alright. So you see, this is another way of finding the gradient, right? So gradient has many ways of finding it. Either one, if you can see the equation, you can read off the gradient as the m value. But if you don't have the equation, you need to work it out using rise over run, which is by getting the values from the 2 points. Okay? Let me see if they will ask you a harder one. Oh, not yet. Okay. Okay. Let's quickly go through these examples. Question 2. What is the gradient 2a?
5.
No.
7.
Still wrong. Close.
Negative 7.
Negative 7, right? Or m equals negative 7.
Okay.
What's the gradient of question B?
Negative 3.
Negative 3. M equals negative 3. What's the gradient for C?
Negative 11.
Negative 11. The gradient for D?
Negative just 0.
No.
Wait, negative 1.
Negative 1, yes. Now, question 3. Which is steeper? 3a.
The first one.
The first one is steeper. Why?
Because it's higher. Like it goes around the y value higher.
No.
What?
Steeper, what are you looking at?
Like 5. 5 is higher, so it's steeper.
And what does the number 5 represent? 5 is the...
Y?
No.
Axis.
No.
It's higher, what do you mean? It goes higher. It's a rise.
Not rise. What is M?
M is a gradient. So it's a gradient. 5 is a gradient.
Mm-hmm. Keep going, yep.
So that's it. So 5 is a gradient.
And and the other line, what's the gradient?
4.
Uh-huh.
And 5 minus 4?
No.
5 is higher?
5 is higher than 4.
Yeah, okay.
So the gradient of the first line, which is 5, is higher than the gradient of the second line, which is 4.
Okay.
Hence, the first line is steeper. Alright, so the answer is y equals to 5x.
Okay.
Question B. Give me the answer and give me the reasoning first and give me the answer.
It's gonna be the first one.
The first one is steeper, why?
Cause wait no, the second one is steeper.
Why?
Cause it's bigger.
What is bigger?
No, the gradient.
Which is?
9.
Yes, it's bigger than the other gradient, which is 7.
Yeah.
Now repeat that.
The 9 is the gradient and it's bigger than the other gradient, which is 7.
Yeah, okay. Yes, make sure you have to say specifically what you're looking at, right? 9, and what does 9 represent? Is the gradient. That's why we're talking about steepness. Right? Question C, last one.
The gradient, the second one. The gradient is 3 and it's bigger than the other gradient.
Yes. Okay, much better. Alright, make sense?
Yeah.
Yeah, so that's interpreting like the y equals mx plus c thing. So now, on paper, find me the value of m for question 5. Let's see if we can do 5a first. Okay, 5a. Remember, what's the other way to find m?
Yeah, so m is the gradient, so m equals and then we do x2 and y2.
Yes, it starts to rise, which is the y stuff. Now it's y2 minus y1 over x2 minus x1, yeah? Okay. Then sub the values in. What are the values?
So it's 5 and 2. 5 minus 2. Minus is a 1 minus 0. That's 3 over 1. So m equals 3.
Yep. Try B. Alright, what's the m value for B?
1 minus 0. And then 0 minus 0, right?
No.
2 minus 0.
No.
1 minus 2 minus negative 1.
No.
Wait, is it left, right? So 0 minus 1.
Okay, so using this one, right? 0 minus 1, right?
Yeah.
And then 2, 1.
Yeah.
If you do it that way, then the top would rise the
Which ones am I using?
this one, right? And this one, right?
Yeah. Okay.
You can either use that one or you can use this one. But let's just say we use that one. So m would be rise. What's y2?
Y2 is 1 minus 0.
Y1 is not 0.
1 minus 2.
No.
Is it 1 minus like negative 1?
Yes, y coordinate. Right? So they give you 3 points here just to confuse you a little bit. If you choose the right point, you find your life a little bit easier. So the other point I will choose is actually this point. What's the coordinate of this one?
1. Wait, no, 0, 1. No, 1, 0, 1, 0.
1, 0, yes.
Yeah.
So let's say we were to use this point, which is 1, 0, then the y coordinate will be 1 minus
0, right?
yeah, over
Over 1 over 2. No, 2 minus 1, 0, 2 minus 0. 2 minus 1.
2 minus 1. Because 1 and 0.
Is that the correct one?
That's the correct order, yes. The other one would give you the same answer, but it's just a bit harder to work through.
Okay.
Right, and then move on to C. So what's the M value for C?
3, 0.
The first one,
Yeah.
what's the coordinate of the first one?
Let me just write it down. So it's 2, 0, right? No, wait. 3, 0.
No. X first.
0, 3.
Yes. Remember, it's the y coordinate, right? Sorry, the y-intercept, right? Which means the x coordinate is always 0. This is the y-intercept, right? And then the y coordinate is the y-intercept.
Yeah.
Now the other one.
That's x has a 1, 1, 3. No, 1, 1, 0, 1, 0.
Yes, if it's on the x-axis, the y coordinate is 0.
Okay.
So know that when you write y2, right, it should be lower. So I think you're writing like y2 like that, the 2 should be lower.
I'm writing it low.
Is it? Yeah, I think your 1 is the one that's a bit too high.
Yeah.
Shouldn't be y1, should be the one is a bit smaller and lower. So most likely that one would need to take up 2 lines. So it's easier to see these are called subscript because they are lower than the letter. Alright, they're called subscript. Alright, what are the values?
We have for y, we have 3 minus 0.
3 minus 0 over
1 minus 0. No, 0 minus 1.
0 minus 1. So what you're choosing is you're choosing this point to be point 2. Right? And this is point 1, which is okay. In fact, it doesn't matter which point you choose as point 1 and point 2. Okay? As long as you take the x and y values from the same point, you will get the same answer still.
Okay.
So the gradient is
3 over negative 1.
which is
Negative 3.
negative 3. Okay. So yeah, do you understand the rise over run, the x, y2 minus y1 stuff?
Yeah.
Yeah? Okay, let's move on. So moving on, application. So look at this example. I think this is the stuff that you most likely will get examined on. Without looking at the answer, what is the answer for A? What is the formula for the distance D traveled by the car in T hours? What do you think?
100 kilometers. Huh?
It's an equation. Formula, right? Let's talk about an equation. So form an equation with
D over T? Is it D over T?
Not quite.
It's 100 kilometers over 100 kilometers an hour, so that's D over T, right?
You mean D over T equals 100?
Yeah.
Yes. Now the easier way to interpret this is the distance of, that is traveled is how long he's traveling for, which is T times by what the speed is, right?
Okay.
So you write it as 100T, like that.
Alright, yeah.
Okay. Now B, what's the gradient of this straight line graph?
Is it 100?
Yeah, it is 100. That's right. It's just the coefficient of T.
Okay.
Yeah? Easy?
Yeah.
Alright, moving on. Let's see if we can find the harder ones. Prepare table of values. Plot the graph, give the formula of V in terms of T. Okay. Let's see. So for this example, right? Do you know how to prepare the table of values?
No.
No. Okay. Show how much water is in a container at 1 minute intervals. So keyword 1 minute intervals from 0 to 6. So what they're saying is, so the time, right? The time would go from 0 and 1 minute interval. So 0, 1, 2, 3, 4, 5, 6. Yeah. And then the other one, how much water is in the container, which is the volume. Right, so you see, the hint is, look, if you look forward, the volume is T and then the time is T. Sorry, volume is V, the time is T. So you're basically making a table of T against V. I want V against T. But yeah, so you're calculating the volume for each time value. Okay, so when time is 0, what's the volume?
So in 0, it's just 0.
It's just not 0.
Wait, 10 liters,
10 liters, yes. And then 1?
It has 15 liters, 20, 35, 25, 30, 35, and 40. Okay, alright. So it holds a maximum of 40 liters only. Alright, so that's all of the values that you need. So this is essentially the answer for question A. Okay. Yeah, so that's what they mean by table of values. Just for each time value, find the volume. Alright, and if you were to plot the graph of V against T, you would get some sort of graph. So let's just ignore the graph for now and see if you can give the formula for V in terms of T. What kind of relationship is this? Is this a linear relationship? Does it increase at a constant rate every time unit? Yeah.
Yeah, it increases at a constant rate of 5, right?
Yeah.
So this is a linear equation. What's the formula for a linear equation?
V equals 5t. No, 5t. 5m. 5l.
Okay, I get where you're coming from. The answer is mt plus c. Remember, it's always m and c for the what's m?
The gradient.
Yes, what's c?
Is it 1 minute?
The
intervals.
No, it's not 1 minute. It's the y-intercept.
Yeah.
So y is the vertical intercept. In this case, it's not y anymore. So c is basically the vertical intercept.
Yes, isn't that 1 minute though?
No. It's the volume when time is 0. And do we know what it is?
40 liters. Oh wait, no, 10 liters.
10 liters, yes. This is literally the column that gives you the y-intercept, right? Imagine if this is x, right? If this is x and this is y, it's the same when x is 0, y is 10.
Yeah, okay.
So the y-intercept is 10, which means c is 10. So now let's update our formula, mt plus 10. How do we calculate the gradient?
We do substitute m, runerize the idea.
Say that again.
We do x, y2 and y1, x2 and x1.
Yep. Which points are you going to choose?
I'm gonna use
Make your life
the
easy.
The last ones?
Nah.
Can I use like 1 and 2? The first one, the second one?
You can use the first 2 points, which actually are these ones.
Okay, yeah.
Alright, so what's y2?
It's it's 10 and 15, 15 and 10.
15 and 10, and x2, x1?
1, 0.
1 and 0, yeah. So which is?
5 and 1. 5.
Yeah, so m is 5. So the formula is v equals 5t plus 10.
Yeah.
Okay, so if you notice, right, they actually already told you the answer in the question, right? Because it's increasing at the rate of 5 liters per minute, so it's increasing.
Yeah.
Right? Flowing in, which means it's jumping 5 per minute. That's why the gradient is 5.
Okay.
Right? But then it has 10 liters in the beginning. So remember, the beginning is normally the y-intercept, right? It either goes, so the idea is that from the y-intercept, or in this case the v-intercept, it either goes up in this case or it goes down. So, but this is normally the beginning. Right? This is normally what the beginning value will be. Right? For now. Okay. So that's why it's plus 10. So because 10 in the beginning.
Yeah.
Okay, any question here?
No.
No? Alright. I think in class you will be asked to plot the graph. It looks something like that. Okay. It's just basically the points that you found, it's just put it onto the graph.
Okay.
Okay, not too bad. So 18F is just, we'll probably have to go back and practice on these ones a bit more. Okay. Do you know if you were going to learn 18G?
Yeah,
Because 18G is about quadratics.
Yeah, no, we skipped it for some reason. We're gonna do it last. It's part of 18x though, so like 18x is like extra, so it's like harder.
Yeah. Not all graphs are straight line. Yeah, okay. Graphs are non-linear.
It's like this quadratic investigations.
Okay.
Wait, I think some of them that teacher made. I think this one, yeah. I think this one is teacher made.
Yeah, it's just about quadratics.
Okay.
Um,
And we're also going to do this as an extension.
Graphical methods for solving linear equations. Okay, scroll down. Let me see if there's any other extra stuff apart from this. Oh yeah, simultaneous equation, alright. By plotting. Okay, so you're just learning about graphical methods first, not the actual algebraic method. Will you be learning this next week or?
I think next week, yeah.
Next week?
Yeah.
Okay. Maybe I'll just introduce the idea briefly, both for the non-linear graphs and also for that graphical method thing. All right. The best way is just to show you on decimals here. Okay. So let's just say I give you the equation that y is equals to x squared. right? So for each x value, y would be the square of that value. So let's just put a few values in. When x equals 1, y is?
1.
1 squared, which is?
Just 1.
Which is 1, yes, okay. Alright, so I'll just label these points in. When x equals to 2, y is?
4.
4, yeah. When x equals to 3, y is?
9. 9.
9, right? X equals to 4?
Yeah.
Y is?
16.
16, okay. So let's plot these bunch of points in here. Now, how about we go negative? So far we've got these points, right?
Yeah.
How about we go negative? And hang on, let me change the x-axis to -5 to +5. Okay, so x is, let's say x is 0. What's y?
X is 0.
The square of that.
Just 0.
Is 0, yes, okay. So when x is -1, what's y?
-1. No, a +1, just 1.
+1, right? Because when you square negative, you just get a positive. When x is -2, y is? 4, okay. You see where I'm going with this? Alright, so I'll plot the next few points in, -3, 9, and let's say the last one, -4, 16. Okay, so if we have that equation, y equals to x squared up here, right? Does that look like a line to you?
Yeah.
You sure?
Yeah.
Like a straight line?
Yeah. No,
Can you draw a straight line going through?
No, yeah.
You can't. No, you can't draw any straight line. Like this one doesn't go through these points here.
Yeah.
And then this one doesn't go through these points here.
Yeah.
Right? In fact, you can't even draw a straight line through any 3 points.
Yeah.
Yeah. So this is an example of a non-linear graph. So if you were to sketch it, the best sketch you can do is like try to cut through all the points, and it kind of like has to go through here, and then it sort of goes like that. This is called a parabola. Okay, and this is what you will see next when you see it at school. Now, if I were to put this in properly as an equation, you will see what the graph actually looks like, which is y equals to x squared, like that. Okay?
Yeah.
So this is called a parabola.
Okay.
Right? Where it's symmetrical around the center, and for all x negative, the y will just be positive, because when you square that, it becomes positive, right? And the graph looks like that forever. It never comes back in, it always comes out like that.
Okay.
Okay?
Yeah.
So yeah, so that's an introduction to a non-linear graph, and when you start putting squares into the equation, that's when you start getting non-linear graph. So what happens? What happens if I put in a different equation where it's power 3, so y equals to x cubed, right? And then let's say plus 2x squared minus x plus 1. So that's 10. Okay? That's not a straight line.
Yeah.
Right? In fact, you will learn about these kind of graphs where it's power 2, power 3 and above in grade 10.
Okay.
Okay, so 2 years from now, you start learning more about these kind of graphs. Alright? And so that's just an introduction to non-linear lines. And basically, they'll just ask you to sketch. So they essentially will just ask you to sketch all these points, right? Sketch these ones, and then do a hand-drawn graph through these ones. So you need to draw a very nice curved shape through these points. Yeah. That's it.
Okay.
Okay. Now the other one that they asked you to do was this. It's the idea that when you have two lines, the solution to the two lines is the intersection of the two lines. So for example, if you have y equals to 2x plus 1, that's one line.
Okay. Yeah.
Right? And then the other one, y equals to, say, negative 4x plus 2. Or 2x plus 4. Okay, let's say this one here.
Okay.
So these are the two lines, and the blue line where they actually meet, which is the point 1, 3, this is the solution to both of these lines. Because when you think about it, it makes sense. This point is on the blue line, right? It's on the blue line here.
Yeah.
Which means when you sub 1, 3 into the equation, so minus 2 times 1 plus 5, the answer should be 3. So that'll be minus 2 plus 5, which is 3, right? So that's correct. It's on the blue line.
Yeah.
Yeah? But this point is also on the red line.
Okay.
Right? So if we substitute 1, 3 into this equation, you get 2 times 1. So we sub x equals to 1. That would be 2 times 1 plus 1, which is 2 plus 1, which is 3. So that's also correct. The 0.13 is also on the red line.
Okay.
Okay? Yeah, so that chapter is essentially saying that the point where the two lines meet is the solution for both of the lines.
Okay.
Right? Because it's on both of the lines.
Okay.
Make sense?
Yeah.
Yeah. So you might be asked to sketch 2 lines and just read out the point that they meet together. So so you would actually, so you won't see this one, but then they most likely ask you to sketch the 2 lines on the graph paper and find out where it meets, which in this case is the 0.13, 1,3. So they ask you what's the solution to this systems of the equation, like what's the intersection of the 2 lines. The answer is like 1,3.
Okay.
Okay, make sense?
Yeah.
All right. So yeah, so I think that should be all of chapter 18. Yeah. So the last one, 18G, is just the parabola there. Right, the point that I showed you earlier, you just got to draw that graph. Okay, and 18X is the one I just told you, the one where 2 lines intersect and then you read out the answer.
Okay.
All right. Okay, that's it. Do you know what your exam is?
No.
Okay. Hopefully it's not too soon. But yeah, so next week most likely we'll go through the harder ones, either the challenge exercise from this chapter or whatever other chapter that you want to go through first. Okay.
The exam's not going to be anytime soon, I don't think.
Oh, okay.
Might be further in the year. Maybe further in the term.
So this is, what week is this?
This is week 4, we're going into week 4.
Okay. So we've got a few more lessons. But yeah, I'm going to focus a lot more on the challenge questions. Just because I was saying, did you ever go to talk to the teacher?
No, I think parent teacher interviews are next week.
Okay.
No, this week, yeah, Wednesday.
Okay, alright. I'll ask her afterwards.
Okay.
Okay?
Bye.
No worries, see ya.